My name is Massood Moradkhan. I'm the Director of Government Relations with pH7 Technologies. And first of all, I would like to thank the MICA team for selecting pH7 and also funding our project. And the second thanks to, again, MICA for giving us this opportunity to present our innovative technology. So basically, pH7 is a relatively a young company founded in 2020, operational in 2021 by my good friend Mohammed Mohammadi, who is also an expert in mining metallurgy. We are basically offering an innovative solution, which is a process that increases the extraction of critical metals vital to the renewable energy transition of the future. So that's basically the purpose of our company. We are working currently on PGM, the precious metals, platinum, palladium, rhodium, and we are processing the recycling materials and extracting these metals. I'm happy to say that we are in the verge of commercialization of our process with a 5-ton capacity processing plant in Greater Vancouver area, which we believe within the next 2 months it will be fully operational. So currently doing that on the PGM, and we are now concentrating on copper for extraction of copper. So our process is basically a very cost-effective and environmental friendly, and that's the reason that we are actually operating in the vicinity of all residential area in Greater Vancouver, because we have no waste, we have zero carbon footprint, and extremely low energy consumption, and practically zero water consumption, which are all important aspects of mining, especially when it comes to copper, or for that matter, any of the other mining materials. I believe this is a very self-explanatory slide. We all know what are the challenges for the copper mining industry. The demand for copper is on the rise due to the electrification and the future demand for the energy transition. The supply is depleting due to the mining, lowering the availability of the mining material. One of the biggest challenges of the mining industry is basically the high intensive energy use. And of course, add to that a huge amount of fresh water use, plus the off-gassing and the toxic emissions that are extremely important. And all of that, the incumbent technology of extracting metals, copper, they are detrimental to the environment with a very high carbon footprint. So what we are offering is actually a closed-loop metal extraction solution. That again, as I said, we are commercializing it for the platinum group metals, and we are concentrating on copper right now. So what we are doing is actually extracting the copper from the trapped copper in the low-grade sulfide ore from the copper mines that are considered right now not viable economically. So we can actually extract that copper with a much lower energy use in a closed-loop system with no off-gassing, a fraction of water usage with zero carbon footprint. The methodology is, I'm sure everybody in the mining industry, in copper mining industry, is basically a heap leach. But the heap leach right now is being used for the oxide ore. And we use that same methodology of the heap leach for the oxide, the low-grade oxide ore. So we will basically irrigate our solution, our chemistry, on the oxide ores, and we collect the solution, and then we use the solvent extraction and electrowinning methodology to extract the copper from that low grade, from that solution. Needless to say that this process, we are also designing a specialized electrolyzer system, which will also produce hydrogen right at the mining site. Basically, based on the MICA project, we are the funding for the project is to design and develop the construction of 20 separate reactors, which we will use for the low-grade sulfide ore, and it will be mixed with our chemistry. So through this project, we will validate our chemistry, we will validate our process, we will validate our process, and also the recovery of our leaching. And whoever that is partnering with us and providing us with the low-grade sulfide ore, we will share the full data that shows our recovery and also the production of hydrogen. So it will be a proof of that project, but this pilot will be done at our own site. It is not a mining site. We will hope that after the completion of this particular pilot program, we will move into a mining site to actually implement that in a larger scale at a copper mining site. So what the MICA is actually funding is a demonstration at our own site in Greater Vancouver area. This is basically just a graph representation of a heap leach, which basically shows that the material will be on the heap, and then of course the irrigation of our chemistry and solution on that material, and then collecting the pregnant solution and put it through the solution extraction, the SX and EW, in order to extract the metals right, producing 99% plus purity of copper right at the mining site, plus a significant amount of hydrogen, which could be used as a different alternative source of energy at the mining sites. That will again help any of the mining companies to use that energy from hydrogen to offset their other different type of energy use. So the importance of this is giving that option without the interruption of their current methodology of the mining operation. So that is another significant issue from our process, that we will not be interrupting any of the current operation of the copper mining companies. So basically, again, I believe this is fairly self-explanatory. From the copper mines, of course, they do have a selection of finding copper material at a cutoff grade. Above the cutoff grade, we'll go through the process of comminution, and then it will go through the concentration making, and then it heads to the smelting facilities. So pH7 technology can come in at two different stages. As you can see, the waste rock, or what they consider as not viable right now economically, we can take that and process that and extract the copper with a highly pure copper. And also we can come in even after the concentration phase and use the concentrated material as our feed in order to extract the copper. So all in all, it will save a lot of money for shipping the materials to the smelting companies generally halfway around the world. And we all know that the smelting facilities are extremely energy intensive, and they are extremely pollutant and detrimental to the environment. So we can come in at both phases, but at this particular moment, we are only concentrating on the first, which would be the processing of the low-grade sulfide ores. The benefit to our process is basically a much lower capex and opex, extremely energy efficient, high recoveries. It is a closed loop system, so whatever the chemistry is and we extract the metal, the chemistry, the solution will go back to the beginning for the irrigation. So that's why the usage of water is less than 1% of the incumbent technology. And of course, it adds an additional revenue stream to the mining companies without interruption of their current operation. And then again, at the end, producing green hydrogen, which is a good source of energy, a clean energy for the mining operation. We are currently collaborating with major Fortune 500 companies, BASF, Johnson Matthey, Mitsubishi corporations. These three companies are already providing, we have a supply purchase contract with them. They're providing us with the recycling materials in our commercialized plant in Vancouver, and we are recovering the PGM metals for them. So these three companies, we are working very closely with them, and they are providing us with the material. And of course, we are collaborating with major universities back in BC, in University of British Columbia and Simon Fraser universities. Most of our R&D team are graduates of PhDs from these two universities. And of course, TDK is TDK Venture, which is the investment arm of the TDK Japan, is a major investor in the company. And of course, with all the government entities locally, provincial and the federal level, because we've been supported by the government at all the different levels through our process, through our endeavor since 2021. I thank you for listening to the presentation. If you have any questions, I'll be happy to answer. And I have put some brochures about our copper aspect of our process right on the desk, and feel free to take one. So.